So let's focus on the movement of heat in a substance a little bit closer. And we've already defined heat as being the energy transferred between a system and its surroundings as a result of temperature difference. What happens is heat flows from a high temperature body to a low temperature body. And we've defined heat as being Q. The amount of heat required to cause a substance to change temperature follows the following equation, which says Q is equal to mc delta T, where Q is our heat change in joules, m is the mass of the substance in grams, delta T is the change in temperature, or T final minus a T initial, so the final temperature of the substance minus the initial temperature of the substance. And in this case, it's going to be in degrees C. So this is one place where we don't actually need to use Kelvin. And C is the specific heat of the substance. And here the units are joules per grams degrees C. And really what we're saying is that with a change in temperature, there's going to be a corresponding change in heat. Some variables in here is mass. So if I have more of something, it's going to be harder to heat it up. We also have a constant for the substance. So different substances are going to react differently to heat. A certain amount of heat going into a substance results in a change in temperature. Not all substances react the same. So we need a constant here to represent the substance. So the specific heat is a measure of how easily a substance changes temperatures with the addition of heat. And the specific heat is actually different for each substance. So this is a constant and you can easily look it up. So in a lot of thermochemistry, we're going to be using water, and the specific heat of water is 4.18 joules per gram degrees C. When we look at this equation, we can see that when Q is positive, we have a positive delta T. So if we're putting energy into a system, the temperature is going to increase. So as the temperature increases, that corresponds to heat being absorbed. The exact opposite is true. When Q is negative, delta T is negative. So temperature decreases when heat is being given off. And this is an important idea. A positive Q means that my system is absorbing heat. A negative Q means that my system is giving off heat. And we're going to be seeing that quite a bit throughout this chapter. So here we're going to look at a single body problem. I have a cup of water and the temperature drops from 60 degrees C to 37 degrees C. I know how much water I have, 250 grams, and I want to see how much heat is being given off by this water. So I use this equation, Q is equal to mc delta T. Remember, I want to figure out what variable I'm looking for, so I'm asking for the heat transferred, so we're looking for Q. M is the mass of the water, so that's given here. C sub S is the specific heat of water. It's a constant. It was given. And then here, delta T is T final minus T initial. And this is the one place where you need to take a second and look at the wording of the problem. It says that we are going from 60 degrees to 37 degrees C. My final temperature is 37 degrees. My initial temperature is 60 degrees. And then when I do my calculation, I get that the amount of heat transferred is negative 24.1 times 10 to the third joules. It's going to be quite often that heat transfers are going to be reported in kilojoules, so there's going to be quite a bit of conversion between joules and kilojoules. The one thing that's important with thermodynamic questions is you can take a second and say, does this make sense? During this question, the temperature of the water is dropping so that we know that the water is giving off heat. So it makes sense that my Q is negative. So Q negative means that my system is losing heat. If you lose heat, you lose temperature. So we expected our answer to have a negative number.